So the first thing to notice and write down is x-intercepts hit the x-axis when y equals 0. Okay, so for this problem, 0 is x minus 5 times x minus 1. The nice thing about factored form is that if you multiply two numbers to get 0, one of them has to be 0. So x minus 5 is 0, or x minus 1 is 0. Moving things over. Okay, so this is one of the reasons we had to learn how to factor things and not just FOIL them. So if I graph this, I'm going to graph 5, 0. Let's see, 1, 2, 3, 4, 5, 0, and 1, 0. Okay, and we know that this is an upside up parabola because there's no negative sign in front. So where is the vertex if it's not in vertex form? Let me try and draw that better. Okay, so the vertex is halfway in between because it's a parabola, so it's symmetric. What's halfway between 1 and 5? 3. So the vertex is 3 comma something. Let's see if we can find the y-coordinate. 3 comma what? Well, plug in 3 in for x into the original equation. And we get negative 4. So my vertex is at 3 comma negative 4. And that looks plausible. Okay, this one, a little thing to note, it's upside down and stretched. So the stretch sort of comes out in the wash when we find the y-coordinate of the vertex, but it's important to notice that it's upside down so that the y-coordinate we get is a plausible number. So we have x-intercepts. What about negative 2? Well, negative 2 can't equal 0. And it doesn't have an x. If there was an x, if it was negative 2x, negative 2x would equal 0 when x was 0. Okay, so when we graph this, let's see. Negative 4 and 2. And upside down and stretched. So probably pretty tall, but I'm not drawing in the y-coordinates, so let's just find that. So how do you find midway between two numbers if it isn't really obvious? Oh yeah, you find the average, midpoint stuff. Too many E's, sorry. So x is negative 1 at the vertex. Here, let me draw in some points. Negative 4, 0, and 2, 0 were my two x-intercepts. And this will be 1 comma what? Well, negative 1 comma what? Okay, so that's going to be positive because the negatives cancel. 2 times 3 is 18. So negative 1 comma 18 is my vertex. Okay. Now in vertex form, we can do the same sort of things. We get the x-intercepts by getting y equals 0. The y-intercepts, how do you do y-intercepts? Could it possibly be that the x-coordinate is 0? Why, yes, Dr. Peterson, it certainly is. Okay, so x-intercepts how do we solve this? We solve it with the square root method. Don't forget to add 8 first. And then don't try and distribute the 0.5. Divide by 0.5. Okay, so adding 8, we have this. Okay, square root. I'm going to move the x minus 3 to the other side. Plus or minus, don't forget. Little note. Okay. Moving the 3 over, don't forget to switch the sign. You're adding 3. So I'll put a little note for that. Okay. 3 plus 4 is 7. 3 minus 4 is negative 1. So if I graph this, I'm gonna graph this way over on the right here. First thing I'm gonna do is have 1, 2, 3, 4, 5, 6, 7, and negative 1. Okay, y-intercept, x is 0, so plug in 0. Negative 3 squared is 9. Half of 9. And 4.5 minus 8 is negative 3.5. So the y-intercept is down at negative 3.5. This time it's the x-coordinates that's 0. Okay. Vertex. This is vertex form, so don't forget we can just take the 2 numbers. Let's see, I've got little hash marks. I'm going to keep going. 4, 5, 6, 7, 8. So 3, negative 8. Okay, other points. And this is following in class, the notes and problem set to 52. Instead of adding 1, 3, and 5, we add half of that. And you won't need to go up 5 halves, but because that'll give you even 2 more points. Okay, so if I start at 3, -8, up a half is up to -7.5 on either side. So 2, -7.5 and 4, -7.5. And then up 3 halves. So let me write that down. Is up to -6.5. So 1 further to the left so we backed up 3, 2, 1, and we're at 6.5 on either side there. So we have okay, and then notice there's a point symmetric to the y-intercept also. 6. So notice that we are going 3 for the vertex, and then 4, 5, 6, 7 to go to the right, and also symmetric point on the left side. Make a pretty graph of it, and we're done. Isn't that beautiful?